Welcome to Study Loop.
19.49. So we have two capacitors whose values we don't know, and it's what we're wanting to find is the value of each of them. And in parallel, we're told that they produce a capacitance of 35 microfarads, and in series, they produce a capacitance of 4.8 microfarads. So this is good. We have two situations with two things we don't know, so we should be able to determine both of these. So what we should call Cp for the values in parallel is C1 plus C2. And then Cs are 4.8 microfarads. It's going to be equal to C1 times C2 over C1 plus C2. And so now we need to solve these for the two capacitances that we don't know. Cs and Cp are known. C1 and C2 are what we're looking for. So, looking at this, we can see that the series capacitance, we can put in Cp here, and we can also, or we can, maybe a little more useful actually, is rewriting C2 as Cp minus C1, because that gets rid of C2 from this equation. And so that gives us that the series combination gives us Cp thinking of it backwards. Series combination gives us C1 times Cp minus C1 over Cp. And then this means that C1 squared minus Cp C1 plus Cp Cs equals 0. And so then we use the quadratic formula, because this is a quadratic equation in C1, to find that the value of C1 is either 29.3 microfarads or 5.7 microfarads. Unfortunately, both of the roots of this are positive, so we can't tell right off the bat which one is right. However, we know the value of C2 is Cp minus C1, and we see here that this is either 5.7 microfarads or 29.3 microfarads. So we aren't able to resolve which one is which makes sense because there's nothing distinguishing between them. We could call this C2 and this one C1, and similarly here, and get the same values of the capacitances. But if we assign one value to one and the other value to the other, then one of them is going to be 5.7 microfarads, and the other one is going to be 29.3 microfarads.